thing now. Oops. All right. Enzymes. First, some vocabulary. Basic terms that you'll need in order to understand this concept of enzymes. What is an enzyme? It's an organic molecule, pretty much always a protein. It's always, for our purposes, going to be a protein. And it speeds up the rate of a chemical reaction. Enzymes are often referred to as catalysts, which they are. A catalyst is just something that speeds up a chemical reaction. And there are catalysts that are not enzymes, but every enzyme is a catalyst. It's like squares and rectangles, right? Every square is a rectangle, but not every rectangle is a square. Kind of the same idea. Catalysts are a broader category. Enzymes fit within that. Not super critical that you understand that relationship. Just know that enzymes speed up chemical reactions. They're sometimes referred to as catalysts. The substrate that I'll be talking about is what the enzyme binds to. So an enzyme, which you can kind of see down here in this figure, this little teal colored thing is the enzyme. The substrate is what the enzyme is helping to create a reaction in. So in this case, it's breaking apart this dark blue substrate into two separate pieces. So the substrate is what the enzyme is working on, what it's helping to speed up the reaction within. Enzymes have what are called active sites, where the substrate binds to the enzyme. So you actually do have kind of a bonding situation going on. You have the enzyme molecule, the substrate molecule, they come together, and the active site is just where the substrate bonds to the enzyme.
So the substrate is the actual thing, not the process?
Exactly, yeah. The substrate is what's really of interest, right? So the substrate is what we want to break down or put together. And an easy way to remember the active site is where the action happens. And when those two are bonded together, when you have the substrate and the enzyme bonded together, you get what's called the enzyme substrate complex. Once the enzyme is done doing whatever it needs to do to make that reaction happen, whether it's breaking things apart or putting them together, it all just dissociates. So the products will go off on their way, the enzyme will go off on its way to do the same thing kind of over and over again. So the enzyme doesn't change after the reaction's complete. It just releases the products and then finds another substrate and does the same thing just over and over again. Okay, so I think with that, we can get into kind of how enzymes work. So here we have a very familiar looking graph, hopefully, with free energy and then this time or progress of the reaction on the x-axis. So same idea here. Would this be endergonic or exergonic? Exergonic, yep. So you have the products with less energy than the reactants. That means it's exergonic, energy has been released. So what we're doing here is basically just switching what's bonded to what. So at first A is bonded to B, C is bonded to D, and we want to end up with A and C together and B and D together. So we're just switching what two things are bonded to each other. And that first energy hump that these reactants need to get over is called activation energy. So activation energy, or E subscript A, is where the enzyme comes into play. And I'll show you what I mean by that on the next slide.
Does that also have to be for endergonic, or is it just for?
Yep, for endergonic as well. Yeah, good question. So this could be an endergonic reaction graph as well. You still have this hump that you need to start out with. That's going to be the activation energy. You'll just end up with the products up here. Yeah, very good question. Okay, so activation energy is kind of like it sounds. It's the energy needed to activate a reaction or get a reaction started. So this is without an enzyme. There's no enzyme yet. We don't have any help from an enzyme. And so that black line would be kind of like what we were just looking at without an enzyme. This red line is what it would look like if we have an enzyme introduced. So for you guys on Zoom, the red line, just the activation energy, what an enzyme does is it decreases the activation energy. So that is the main goal and function of an enzyme, to decrease the activation energy in a reaction. And that's why it's circled here. So if we didn't have the enzyme, we would need this much energy to get it started. With an enzyme, we only need this much energy to get it started. Yep, the energy needed to get it started. Yep, exactly. It's going to bring it down, which obviously makes the reaction happen a little faster. You don't need as much energy input, so it can get going a little bit quicker. A really important part of this whole enzyme concept is that the final energy, change in energy, does not change, right? So whether you have an enzyme or whether you don't have an enzyme, the red and black lines both end at the same level of free energy. It doesn't change the overall result of the reaction as far as energy goes, the final kind of net energy. It just decreases this initial input. So delta G is unaffected. You don't get more energy released or less energy released because you have an enzyme. The same amount of energy is either released or required if we're talking endergonic. It's just this initial getting started energy, that activation energy, that changes. Okay, any questions about that? If you don't learn anything else about enzymes, just remember enzymes decrease the activation energy. Remember that phrase. But learn a little bit more about enzymes because I'm going to tell you a little bit more. You don't need to know this whole cycle. I just kind of want to give you an idea of how this works because it's sort of, I don't know, maybe a little bit hard to conceptualize. Here we have the substrates. They're the little green and orange pieces, or this big purple blob is the enzyme itself. So it all comes together. So you have the active site, which is actually shaped specifically for very specific substrates. So enzymes are very specific for what molecules they can work on. So this enzyme matches up perfectly like little puzzle pieces with these two substrates that need to get bound together. So that enzyme substrate complex forms. This is where that lowered activation energy comes in. So now, rather than if these two substrates were just off on their own trying to bond together, they need a lot of energy. The enzyme is basically making it a little bit easier for them to bond or do whatever the heck they're doing here, changing into two different things. So they're converted, it's going to convert those reactants, the substrates, into the products. and then it'll release them, like I said before. So it just lets them go after the reaction is done, the enzyme does.
Can they be reused, like your products become substrates again, or are they just?
Eventually, yeah, in a long cycle, they may, yes, depending on what it is. The important part is that the enzyme can be used right away again, right afterwards. Yeah. So depending on what this is, there might be a long path back to them becoming substrates again, but yeah. So the enzyme, once it releases the products, it's open and available to do the same thing, basically the same substrates over and over again. Okay, so that's generally how an enzyme works in a basic sense. How well enzymes work are affected by a few different factors. Temperature is really important. Our enzymes in our body work best between 95 and 104 degrees. So if your body temperature goes into the hypothermic or extremely feverish category, a lot of the reason you can die from that is because your enzymes stop working. So your enzymes, your physiology basically shuts down because enzymes aren't able to make these reactions happen anymore. So a lot of times they just don't happen.
Like when your body's going into shock, like hypothermia and all that.
Hypothermia, or on the other end, if you have like a fever of, I don't know, something insane, 106 or something like that. Ideal pH is kind of right around that neutral, so 6 to 8. And then there's also things called inhibitors and cofactors, which we're pretty much out of time today, so I'll just stop there. We'll talk about inhibitors and cofactors that obviously inhibit the work of an enzyme if they're present, or cofactors are going to sort of help the enzyme be a little bit more efficient. But I'll talk about them on Monday. All right. And don't forget to turn in that worksheet by Monday, and have a good weekend.